Okay, we're in section 14 of the SAGE code, and we're going to talk through it. Again, for the students that want to use the interactive co-calc, just click on this magenta link and it'll bring you to the website and do the interactive co-calc if you prefer. The only real difference is in the interactive co-calc, it's web-based, using somebody else's computer, and instead of hitting the return, you have to shift return for it to get the execution. Whoops, sorry about that. I keep doing that, don't I? Reset. And then I'm going to type in T as a variable. This has a lot to do with what we've covered in this section over here. Hopefully you're studying these sections to learn the material. And that does take a lot of time and effort. S is a function of T, and it's being assigned T squared minus T. We'll look back over the notes later and see if this problem was actually given to you. All right, for you to either try or for me to do in front of you. Already did that. And then next thing up is ds. ds is a function of time. And what is it? It's actually the derivative, diff. That means differentiate. st is the function s of t with respect to t. Got ds. Equation 1. Let's write this down for you. eq1. We'll look back over the notes later. Equals, I'm getting a little tired. So what I'm going to do, I'll just copy this down. Look back over the notes. Solve eq1 for t. Okay. Yeah, we'll look back over the notes, and I want to see if I see something like this. And this is what we're trying to do, trying to get a connection between software and what we just did by hand, or maybe that you didn't do it by hand yet. Maybe you're going to do this later. Whenever you get ready, you want to start working towards a goal. All right. My goal over here, I'm looking for this st, t squared minus t plus 10. Now, I know it's tough looking back over the notes, by the way. We're looking for t squared minus t, right? Now looking, isn't there? Wow, it's right there, number 2. Let's read through it. Position of a particle moving in a straight line during a 5-second trip. St is equal to this function over here, which is t squared minus t plus 10. I did define it. Find the time t, which the instantaneous velocity is equal to the average velocity of the entire trip. Whoa, that's a tough one. Let's look back over our work. We've done this problem already. So what do? S0 is 10. I see that right over here. S5 is 30. I see that written over here. And then I see the average velocity written down, which is ds dt. Well, that's 30 minus 10 over 5 minus 0. And they said it's equal to 4. All right. All right. Let me just take a look at this right again. ds dt. Equation 1 for t. Yeah, I see that now. All right. So I want to type this in though. That's 4. Well, I said it's 4. This is good news. What's st? Let's see if I got st right. All right, so I'm gonna type this in now. Again, I'm trying to learn. Well, I say it's 2t minus 1. All right, and then someone says, I wonder what this business is over here. Well, what I'm saying is I'm assigning to it the derivative to the average speed. And I'm wondering what value of t that would occur at. And that's what this thing's given. And what do I say the answer is? Well, according to Sage, it's 5 over 2. According to this, says it's 2.5. Is that the same? Of course it is. It's 2.5. 5 as is 2.5. So here's the deal. You start to say, why do we give you Sage? So you can look back over and see how it applies to these problems. Now, if you have really short memory, you can't remember doing any of this stuff, it has no recollection. You'll have no recollection of what we've just done. It's good to think. The more you think about this, the more recollection you'll have. All right. So if you want, you can go back over the notes and, maybe think about some of the problems again, think about how Sage relates to it, and maybe start to play around with Sage. All right. Thank you.